Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. Yet another video, very important for class 10th students because they are the ones who will study this topic of pair of linear equations in two variables. Not that the topic does not exist in classes lower than 10th, it does come in class 9th also, but you don't have this concept that how to find the nature of the solution of a pair of linear equations. So just by looking at the pair of linear equations which is given to us, we can find what type of solution will they have. So what's the entire video? This concept will form a very good base for so many important questions which are asked in board exams. Before taking up the questions, let me just tell you about our Learning Loop app which we have launched very recently, and that particular app is available on the Google Play Store. The link is given here in the description box below. The app contains very nominal costing, validity based ebooks and some video courses based on class 6 to class 10th maths and science. Even Vedic maths is there and the beginner level, and you can watch some free stuff also on the app. This is the logo of the app, so make sure that you are downloading the correct app. The Learning Loop. Let's see the concept in hand first. So when we are talking about nature of solutions of a pair of linear equations in two variables, the equations are represented by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equals 0. Now this pair of linear equations can have different types of solution. That means the values of x and y which will satisfy this pair of equations may differ in the nature. Now how do you find the nature? The nature of the solution depends on the ratio of the coefficients of x, that is a1 upon a2, the coefficients of y, that is b1 upon b2, and the constant terms, that is c1 upon c2. That ratio is going to decide what type of solution will a particular pair of linear equations will have. So let me take it up case wise. The first case is when a1 upon a2 is not equal to b1 upon b2. So when you take the ratio of a1 a2 and b1 b2, these two ratios are different, not same. They may differ in sign also, like one can be 1 by 2 and the other can be minus 1 by 2. Still they are different, right? So when they are unequal, that means this pair of linear equations will always have a unique solution. That means you will have one pair of values of x and y which will satisfy the two equations. That is called unique solution. And whenever you have a unique solution, the graph, when you plot the graph of these two equations, you will always find the two lines intersecting each other at a single point. Intersecting lines are obtained, and the point of intersection itself is the solution of the linear equations. That is the first condition. The second condition arises when we have a1 upon a2 being equal to b1 upon b2. Now whenever the first two ratios, that is this ratio and this ratio, becomes equal, then we have to see the third ratio, that is c1 upon c2. So if the third ratio is not equal to the first two ratios, then we have a different nature of solution. And in case when the first two ratios are equal and when we compare the third ratio also, and the third ratio also becomes equal to the first two, then we have a different nature of solution. So whenever the first two ratios are equal but third one is not equal, it means that the two equations will not have any solution. That means it is called no solution. And no solution means no point of intersection. And which two lines have no point of intersection? Pretty obvious, right? They are the parallel lines, and therefore when you plot the graph of such linear equations, you will always get parallel lines on the graph. In the third case, when all the three ratios become equal, then we can practically say that these two equations are exactly same, because they will have a common factor, and if you remove the common factor from one of the equations, it will lead you to the first equation. So practically the two lines are exactly the same, and therefore all the solutions, that means all the points or the solutions lying on one line will also lie on the other line, and therefore it is called infinitely many solutions. Infinitely many solutions. So whenever the two lines have infinitely many solutions, they have infinite points of intersection on the graph. And which two lines will have infinite points of intersection? When the lines are overlapping each other, and they are called coincident lines. Coincident lines are the lines which overlap each other. So this is how you know the nature of the solution and relate it to the kind of graph which will be obtained by plotting the two lines on the Cartesian plane, right? So in case you have a unique solution or you have infinitely many solutions, the system is called, so in case of part 1 and part 3, that is unique solution and infinitely many solutions, we call the system to be consistent. And in case of the second part, when there is no solution, we call it the system is inconsistent. So no solution means inconsistent. These are the typical words which are used in the concept, and you need to know all these things to solve the problems related to the concept. Let's see the questions which can be asked based on this concept now. Find the value of k for which the pair of linear equations have unique solution. So I have underlined the keywords. We have to find the value of k, and given that the pair of equations have a unique solution. Now the two equations which are given to us are 3x plus 4y minus 20 equals 0 and 5x minus ky plus 14 equals 0, right? Now it is given that the equations have unique solution, and for a unique solution we should know that a1 upon a2 is not equal to b1 upon b2. Now this is the condition I am going to use to find the values of k. So let's put the values. a1 is 3 upon a2 is 5 not equal to b1 is 4 and b2 is minus k, right? I don't need c1 upon c2 because that doesn't relate to unique solution. So when I cross multiply these, I will get minus 3k is not equal to 4 5s are 20, and so k is not equal to minus 20 upon 3. So what does it mean? It means that the value of k, if it is minus 20 by 3, then it may have a unique solution. But in case the value is not minus 20 by 3, it can have any other value, it will always have a unique solution. So k can take any value except minus 20 by 3. That is the answer for this question. Now we can apply this same concept to find the value of k in case infinite number of solutions are given to us. Let's do this. Now for infinitely many solutions, now you should know the condition first. a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So let's put the values. a1 is 2 upon a2 is 6 equals b1 is this k minus 2, the coefficient of y, and the coefficient of y here is 2k minus 1 equals c1, the constant term is k, and c2, the constant term is 2k plus 5. Now you can see we have three ratios, and now we have to solve by taking two at a time and get the value of k, which will give you infinite solutions. So for the first one, you can do it in two ways. See, I'll split it into two parts. I'll take the first and second. This is 1 by 3, right? So 1 by 3 equals the second ratio k minus 2 over 2k minus 1. So cross multiply, 3k minus 6 equals 2k minus 1. So k equals 5. So I got k equals 5 when I equated the first and the second. Now you can equate first and third, or you can do second and third. First is easier, 1 by 3 is easy to handle, so I'll take 1 by 3 again here and equate it to the third one, k upon 2k plus 5. Now if you cross multiply this, you will get 2k plus 5 equals 3k, and so again k equal to 5. See, from both sides you get the same value, k equal to 5, and the common value of these two will be your final answer, which is k equal to 5 in this case, right? Another question where the number of variables are going to increase now. So we need to find the values of p and q, two different variables for infinitely many solutions. So again, the condition remains the same for infinitely many solutions. A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Let's put the values here now. 4 upon the second one, 2p plus 7q equals 5 upon the value of the coefficient of y, p plus 8q equals 2 upon the constant term 2p minus q plus 1. See, I put the values of a1, a2, b1, b2 and c1, c2 in the condition. Now since there are two variables, we will get two equations. So let's cross multiply the first two like this. So what will I get? 10p plus 35q equals 4p plus 32q, right? So this becomes 6p and plus 3q equal to 0. I can cancel 3, so 2p plus q equals 0. If I cross multiply the second and third, or you can do first and third also, I am doing second and third. So this is 10p minus 5q plus 5 equals 2p plus 16q. This becomes 8p minus 21q equals minus 5. So we have two equations which we can solve now using linear equations in two variables concept. That's quite easy now. So 2p plus q equal to 0 is the first equation which I obtained here, and the second one is 8p minus 21q equals minus 5. Equating the coefficients, so 2 and 8, so multiply by 4, so you get 8p plus 4q equals 0, right? This becomes the first equation now. So if you see the second, these two equations, change the sign, negative, negative, and 0 is doesn't contain any sign. So minus 21 minus 4 is minus 25. Q equals negative 5 gives me q equals 1 by 5. And once you put the value of q in one of the equations, I am using this one, 2p plus q is 0. So 2p is minus 1 by 5. So the value of p comes out to be minus 1 by 10. This gives us the values of p and q. So solving a pair of linear equations in two variables, that forms a part of this question of nature of solutions. So friends, very important concept, and I hope you have understood it. Do share it with all your friends. Do subscribe the channel and click the bell shaped icon for getting all the notifications. Thanks for watching this video and all the best for your practice.